This time we don't have a prepared packet tracer file, so we're going to create it ourselves. That is why the first goal in our exercise is to recreate the diagram below. So let's do that. I'm going to add the 2811 router and then the 2960 switches. A little bit of OCD here. Let's rename them to S1, S2, S3, S4, and the router is going to be R1. We're going to connect the switches with a copper crossover cable. S1 and S2 are going to be connected through gigabit Ethernet 0/1 on both switches. S3 and S4 as well. And then S1 and S3 through gig Ethernet 0/2. And the same goes for S2 and S4. And then we're going to connect S2 with the router using a copper straight-through cable. And we're going to connect that to fast Ethernet 0/1 on both devices. Let's add labels. I'm only doing this to help with configuration. You don't actually have to do that. Adding the PCs. For the PCs, we will also use the straight-through cable, and we will connect the PCs to Fast Ethernet 1. So A is going to go to Fast Ethernet 1. But then B is going to go to Fast Ethernet 0/9. And we'll do that because in reality, a switch will usually have around like 12 or 24 or 48 ports. And if you have VLANs in your network, you're not really going to configure a switch all over again just because you add a new host. Rather, you will take some portion of the ports and add them in advance to a certain VLAN so that when you need to add a new host to your network, you can just plug that computer into a pre-configured port. So in this exercise, I'm going to configure the first 8 ports to belong to, in this case on S1, to belong to VLAN 200, and then the other 8 ports to belong to VLAN 100. Let's add the labels there as well. I'm going to say Fast Ethernet, and I'm just going to say /1 because we know it's 0/ something. If you want to use the colors, I'll show you how to do that as well. I'm gonna save the empty diagram just to be able to go back to that. Okay, let's get going then. By the way, if you're wondering why there is a difference between these two, that's because this screenshot is from an older version of Packet Tracer. So no worries, we're using a newer version, so that's why there are some differences. All right, our first task is to configure host names on all devices according to the diagram, and to configure a banner on the router with our names. We already know how to do that. Let's start from switch 1. When we get to the router, it's going to ask us if we want to enter this initial configuration dialog. It's actually something like a wizard. You can do that, just add another router into your working area and try that with that separate router. It's like a wizard. It makes you configure the host name and IP address, etc., etc. We don't really need to do that, and I don't think we will be doing that during this course ever. So if you would like to know what that looks like, just play around with it. It's not real equipment, so you can't really mess anything up. So we're going to say no here, and we're going to go into the configuration mode, host name R1, or yeah, banner, message of the day, cyber quins or whatever, just cyber, and that's it. Second task, configure access interfaces in VLANs. 8 interfaces per VLAN according to the diagram, of course. We're going to go to S1 first, and we're going to use the range command. So interface range fast Ethernet 0/1 to 8. Switch port mode access, switch port access VLAN 200. To move to the other interfaces, you don't actually have to exit. I always type that in out of a habit, but it will work if you type in interface range fast Ethernet 0/9 to 16. It will go into that other set of interfaces. You won't be able to use the tab key if you do it that way, but if you know the command by heart, you can just type it in without exiting this range of interfaces first. So these interfaces are going to belong to VLAN 100. So let's go switch port, mode access, switch port access, VLAN 200. No, VLAN 100. Okay. Exit. At switch 2, we don't have any access interfaces, so we're just going to skip that one. Let's go to switch 3. I swear I'm not drunk, you guys. I've been missing so many commands in this exercise already. Okay. Our next task is to configure the trunk interfaces. So which ones are the trunk interfaces? We're going to configure all of the interfaces between the switches as trunk, but also this interface between switch 2 and router 1. Router 1 is going to be a gateway to all of these computers in here, but they belong to two different VLANs. So we need this link to be a trunk link so that all of these packets, or the packets from all of different VLANs, can actually travel through this interface. And we are, of course, only talking about the switch. The router doesn't really look at that link as a trunk. The router is going to have two sub interfaces configured on top of this physical interface, and it will only look at a VLAN tag to figure out to which one of those sub interfaces that packet should go. All right, let's get to it. So switch 1, and I'm also going to use the range command here because, for example, on this switch, we have gigabit Ethernet 0/1 and gigabit Ethernet 0/2, and they are both trunk interfaces. So I can just say interface range G 0/1 to 2, switch port mode trunk. And then I need to do the same for the fast Ethernet interface going to the router. Now we should let STP do its job. And if you're not familiar with the spanning tree protocol, don't worry, that is what our next lesson is going to be about. You may get a different situation in your topology. For example, you may have this link turn orange, but I promise I will explain all about STP and all about what is actually going on here in the next lesson. In short, we should not have a loop in between layer 2 devices. So that is why one of the links has to break. All right, our next task is to make sure that all of the switches have all of the VLANs. So when we added some of the ports on switch 1 to both of the VLANs, both of those VLANs got created on switch 1. But on other switches, for example, S2 doesn't have any VLANs created on it. S3 only has VLAN 100 and S4 only has VLAN 200. So let's go to S3 first. We're just going to say VLAN 200 because that's the VLAN we're missing. And if you want to check which VLANs you have on a switch, just use do show VLAN brief F command and press enter, and you will see one, which is the default VLAN 100, and then 200, and we don't have any interfaces belonging to VLAN 200, which is perfectly fine because that's what we're expecting here. And then we have some more default VLANs that you will see on any given switch. S2, we need to create both VLANs, and I'm going to show you a trick here. You don't have to exit this configuration mode in order to create the next VLAN. So you can just type in VLAN 200, and then I'm going to exit to say do show VLAN brief, to check if those two VLANs got created, and I can see that they are here. So we are good on switch 2. Let's go to switch 4. On switch 4, we are missing the VLAN 100. So we're just going to say VLAN 100, and that's it. Next task, configure R1 as a router on a stick with a DHCP server for both VLANs. So here I'm going to show you the commands first. So what we're going to do first is, you can see that this link is down. So the first thing we're going to do a no shutdown, which means we will power on this interface and the link will go up because interfaces on switches are automatically up. After that, we're going to create these sub interfaces that I've mentioned. So first we're going to create a sub interface which will serve as a gateway for all hosts within VLAN 100, and we will name it 100. You don't actually have to name it after the VLAN. You can type in whatever you want here. This is actually the command that matters. So here you are putting the number of the VLAN that's going to be in the tag, or this is what the router will look for in a packet in order to decide to which interface it will send that packet. So if the router receives a packet which is tagged with 100, it will know that the gateway of that packet is this IP address. So once more, this is a virtual interface. It's called a sub-interface. And then with this command, we are telling the router, this is the tag in the packet that you should expect to receive on this interface. .1q, as I've explained in the presentation, is a protocol according to which switches encapsulate these packets, or these frames to be more precise. The IP address is simply an IP address of that interface. The command, as you can see, is the same. Like, this is the command you would use on a physical interface as well. And then the second sub-interface is for VLAN 200, and same goes for that sub-interface. Okay, let's do that first, and then we can go to DHCP. Enable configure terminal, interface fast Ethernet 0/1, no shutdown. We can see that this link is now up. We can use fast forward, and now it's totally green. So let's go and create these sub interfaces. I'm going to say interface fast Ethernet 0/1 .100. Okay. And then encapsulation .1q 100, and then IP address 192.168.1.1/24. If you're having trouble with this annotation of the mask, take a look at my other Udemy course called IP Addressing 0 to Hero, where I explain this in great detail. Okay, we're going to go to the second sub-interface, interface fast Ethernet 0/1 .200, encapsulation .1q 200, IP address 192.168.2.1/24, and that would be it. Now, regarding DHCP, hopefully you already are familiar with the DHCP protocol. If not, it goes two ways. So you have a DHCP client and a DHCP server. In this case, the DHCP clients will be PCs and the server will be the router. A client, once it joins the network, will send a DHCP discover message, and then the server will reply with DHCP offer, And then the client will say, okay, DHCP request. I request an IP address that I received as an offer. And then the server is going to send an acknowledgement. So the PC sends a DHCP discover packet, which is a broadcast packet, hoping that that packet will end up at a DHCP server. DHCP server figures out which segment of the network is that packet coming from, and this particular DHCP server, our router, will figure that out based on the VLAN tag. Since we have configured VLANs on our switches, this switch, let's take for example that PCA is sending that DHCP discover message. So switch 1 will look at that packet. It will say, I received this packet on an interface that belongs to VLAN 200. So I will add a tag. It doesn't care what kind of a packet that is. It will always add a tag. And then it will send it through a trunk link, and we can look at the simulation later. Long story short, that packet will end up on the router. The router will look at the packet. It will see that the source IP address will be all zeros, since that PC doesn't even know where it is, which network it belongs to. It is not aware of the VLAN tag, so it will use an all zeros IP address, and that address looks like this. So it's 4 zeros. So that router will look at the source IP address. It can't distinguish much from that, but it can distinguish a lot from the VLAN tag. It will say, okay, so this packet is coming from this VLAN, and the gateway for this VLAN is 192.168.2.1. So do I have a pool configured to give IP addresses that belong in that network? I do. Or when we configure these pools on our router, it will have those pools. So what these commands mean here is, this one is saying to the router, I'm creating a DHCP pool for you. And again, this is a name, it's a random string. You could use your own name here, or you could use numbers or whatever you want. And then you will say network, and this is a subnet or a range of IP addresses that this router can allocate to DHCP clients. And then this command, this is default router, means actually gateway. It's another parameter that this DHCP server will send to its DHCP client. So other than offering an IP address, it will also offer the default gateway IP address. Other things can be set as parameters that a DHCP server can send to clients. For example, the address of the default DNS server. Okay, so those are the commands in this DHCP pool part. But what is this? If, for example, you have an application running in your subnet or a server or anything like that that needs a static IP address, you can make a reservation on those IPs. So you can tell the DHCP server, don't allocate these IP addresses. I need, for example, a specific host or a specific application to always get that IP. And it won't be able to get that IP if that IP is already allocated to someone else. So that's what this is for. Okay, let's move on with the configuration. Let's go to the router. And I'm going to say IP DHCP pool VLAN 100. Or let's exclude those IPs first. Okay, sorry. So we're going to start 192.168.1.0, and then it will end at 192.168.1.10. So it's from to, kind of a command. And then I'm going to use the up arrow, and I'm just going to change the third octet in the IP from 1 to 2. And that's it. Oh, I'm gonna give you a tip here. A common mistake that I noticed back when I was teaching this among my students was they would use this up arrow to show the last command they issued, and they would only change the third octet in the second IP and not in the first one. That way you will really make a reservation for all of the IPs from 1.0 to 2.10. So all of the IPs. So what will happen is your VLAN 100 PCs will not work. There will simply not be any IPs for them to take. So make sure that these are the commands you've used. Now let's make the pools. IPDHC pool VLAN 100, network 192.168.10/24. And then default router is the IP of the gateway 192.168.1.1. For VLAN 100, let's create a pool for VLAN 200, IPDHCP pool VLAN 200, network 192.168.2.0. Default router 192.168.2.1. Now all that is left to do is to go to IP configuration on each PC and select DHCP. And this is the first IP address that's available or that's not reserved. And we got exactly that. We got the subnet mask we configured and the default gateway address that we also configured as default router. Let's go to B, DHCP. We should also get 111, that's right. And then this one should get 112. And then for PCD, I'm going to run a simulation real quick. Once we click on DHCP, we will see a DHCP discover or discovery. Sometimes that is what they use. Discover packet, okay, and sends it out. And then that packet will go to the switch. And since it's a broadcast, it will be sent to all ports. And then, of course, it can only be sent to trunk links or other VLAN 200 links. But let's focus on this packet right here. I don't believe that packet tracer can actually do the entire DHCP communication. It's gonna be lost right here. I think it takes too much time. But we can look at some information here. So source. I'm sorry, let's look at it here. So source IP all zeros, destination IP all ones in binary. That's the default broadcast. And then there is also the DHCP part. Let's try a ping. Okay, I'm gonna use this toggle option. And the first thing you need to test if something is not working is the communication between hosts and their gateway. In this case, the gateway for all of the hosts in this network is this one router. So if that's successful, then you should look at VLAN configuration because this is a pretty simple topology. And then the second thing you should test is communication between hosts belonging to a same VLAN. So let's try a ping between A and D. And that works as well. And then let's try communication between A and B. The first one fails, and that's usually the case, so don't be worried. They usually fail because of ARP, and then a second or third try will be successful. There you go. That is pretty much all of it for this lesson. See you in the next one.